So we've been discussing quartiles and percentiles, and we have been doing examples where we are given the raw data, and we're trying to figure out how to divide it into, well, into quartiles or percentiles. What do we do if we are given data that some analysis has already been done to it, particularly if it's been grouped together into ranges or bins or buckets or whatever we want to call them? So basically, if we're given a frequency table or a frequency distribution here. So here's the example that we're going to work on. A business association rates hotels on a variety of factors, price, cleanliness, services, etc., to produce an overall score out of 100 for each hotel. 100 is going to be a good score. 0, I guess, would be the absolute lowest score you could have. For a major city, they found the following ratings. And they've tabulated them in this table that we see over there on the right. Okay. Find the median in the interquartile range, and then part B, to be highly recommended, a hotel must be in the 90th percentile. What score is needed? So let's deal with part A first. If we're going to find the median and the interquartile range, we have to find all three of our quartile boundaries. We need to find Q1, Q2, which is our median, and Q3. So let's think about first let's do Q1 first. Okay? If we have a total of, well, how many total numbers do we have? We can add up the numbers that we have in each of our frequency column here, and we figure out that we have a total of 50 hotels that were surveyed here. Okay? So if we have 50 hotels, the number that is going to divide the lower 25% from the upper 75% is going to be, well, we're going to have 50 divided by 4 in the lower quartile. So the 12.5 number is the number that divides the lower 25% or the first quartile from the upper 3 quartiles. So this is what we want to find. We want to find what is the 12.5 number if we were to list all of these numbers out in order. Now, I'm going to give myself a bit more room here. First thing we want to do probably is we want to figure out which bin this 12.5 number is going to fall into. And what's going to be helpful as we're doing this question is not just having the number in each bin, but the cumulative number in total. So our first bin, 50 and below, we have a cumulative total of 7. By the time we get to our next bin, 51 and 60, we want to add on that 11. So we have a cumulative total of 18. For our next bin, we have a cumulative total of 27. Our next bin, we have a cumulative total of 27 plus 12, so 37, 39. Our next bin, 39 plus 8 gives us 47. And, of course, by the time we get to our last bin, our cumulative total is 50. So looking at this, which bin is our is the 12.5 number going to be in? Well, it's not going to be in the first bin because we only have 7 there. It's going to be somewhere in this second bin where we go from number 7 all the way up to 18 because 12.5 is in that range from 7 to 18. So Q1 is going to be in this bin. So which number do we want in that bin? Well, we don't know what all of the individual numbers are in that bin, but we know that there are 7 numbers in our first bin. So this is like bin 1. To get up to our 12.5, we need to have 5.5 numbers out of bin 2. Okay, so 7 numbers out of bin 1, 5.5 numbers out of bin 2 give us this 12.5 number that we're going to look at. Okay? So how do we figure out what value corresponds to the 12.5 number? That's going to be our value of Q1. We look first at the starting value for this range. Okay? This range starts at 51. Okay. So 51 is the start of the range. Okay. Now, how far into the range do we have to go? Well, we want to go in 5.5 numbers. Okay. How many numbers are there in that range in total? There are 11 numbers total in that range. So we want 5.5 out of those 11. So the 5.5 is the, I should just say it's this number that we want to go in. So this is like how far into the bin we want to go. And the 11 is the total number of numbers in the bin. So let's just say number in that bin. And then we want to multiply this by how wide the bin actually is. So let's say the width of the bin. Okay. So our 12.5th number is 5.5 numbers out of 11 into that bin, which has a width of 10, okay, and has starting value of 51. So the 51 is like the starting point, and this whole, this fraction times 10 here is how far is the number that would get us this fraction of the way into that bin. So we just multiply this whole thing out, and let's see, and we end up with 56. Okay, so that's going to be our quartile boundary. Okay, that's going to separate the lower 25% from the upper 25%. Okay, so let's try this again with our next quartile boundary, where we're trying to find the median. Okay, so the median is going to be our number that is halfway through. So we want 50 divided by 2, or we want the 25th number in our list. So let's go to our frequency table and figure out which bin that 25th number would appear in. Well, we have 18 numbers up to the end of bin 1, bin 2, and 27 numbers at the end of bin 3, the 61 to 70. So our 25th number has to be somewhere in that third bin, right there. Okay? So we know which bin we're looking in. So our value for Q2 is going to be, well, we go to the start of the bin, so that bin starts at 61. How far do we have to go into that bin? Well, there are 18 numbers in there. There are 18 numbers up to the start. How far do we have to go in? We want to get up to 25. So we have 18 plus, so we want the 7th number in bin 3. And these guys are all in bin 1 plus 2. So we want the 7th value that would be in bin number 3. How many values are there in total in bin number 3? There are 9. So we want 7 out of 9. And how wide is this bin? It has a width of 10. So then we punch this into our calculator here, and we get 68.8, which is our median, or our Q2 value. So one last time here for Q3. Our Q3 number divides our basically 3/4 of the lower part of the data from the 1/4 upper part of the data. So we want our 50 times 3 divided by 4. We want 3/4 of the way, the number that is 3/4 of the way through our data set. So that's going to be our 37.5 value, if we were to write them in order. So let's see. which bin do we have to go to find 37 and a half number? Well, we have 27 up to the end of bin 3, 39 at the end of bin 4, so our Q3 value has to be somewhere in between. So we know that we're looking in bin number 4 there. How far into bin 4 do we have to go? Well, if there's 27 up to the start, we want to get up to 37 and a half. So we're going to have to go in 10 and a half numbers. So it's the 27 numbers in bins 1 to 3 and 10 numbers in 10 and a half numbers in bin 4. So what number is the 10 and a half number in bin 4? Well, let's figure it out. Our starting value for bin 4 is 71. How far in do we want to go? We want to go in 10.5 out of how many numbers are in that bin number 4? There are 12 numbers in there, so we want 10 and a half out of those 12 numbers. And how wide is this range? Again, the bin width is 10. So we punch this in, and we get 79.75. So these three numbers here are our quartile boundaries. Q1 was 56. So we've got our median at 68.8. Let's just highlight it. And what this question was really asking us was to find the interquartile range. So interquartile range, or IQR, is just the difference between our Q3 value and our Q1 value, which is going to be 79.75 minus 56, which gets us 23.75. So that number all by itself doesn't mean a whole lot, but it's useful when you're comparing two data sets to one another. And we're going to talk more about that when we talk about standard deviation in the next lesson. So let's move on to part B here, where they're asking us to figure out what the 90th percentile is. So part B. We want to find P90, okay, or the number that represents our 90th percentile. So if we want the 90th percentile, we want 90 out of 100 of our 50 numbers. So let's see. 90 divided by 100 times 50 gives us 45. So we want, if we were to write these things in order, we want the 45th number in that list. So same thing that we did with our quartile boundaries. Let's go back to our frequency table and figure out which of our bins is that 45th number going to be in. So let's see, we've got 39 up to the end of bin number 4. We want the 45th. So our 90th percentile value has to be located in bin number 5. So how many are there in that bin number 5? There are 39 below it. We want the 45th value. So we have to go 6 numbers into bin 5. So we just think of this as 39 plus 6, 6 numbers into bin 5, and all of these are bin 1 to 4. So our P90 value is going to be, what is the start of bin number 5? Bin number 5 starts at a value of 81. We want to go 6 numbers in, How many numbers are there in bin number 5? Let's go back up and check. There are 8 numbers, so we want 6 out of those 8 numbers. And then once again, we multiply it by the width of the bin. Punching this in, we get 88.5. So the question that was asked here was, to be highly recommended, a hotel must be in the 90th percentile. What score do they need? Let's say a score of, now should we round this up to 89 or should we round it down to 88? What do you think, Kale? Why do you say up to 89? Yeah, you need to be above that number to be in the 90th percentile. If we round it down, they would still be in the, well, in the lower 90% of the data. So we want to round it up in this case. So a score of 89, I'm going to change this to at least 89 is in the 90th percentile. Okay. Because that gets across the idea that if you're above 89, you are still in the 90th percentile. Anything above 89 puts you in the 90th percentile. Okay. And that's how you deal with grouped data.